Hello, hello. So, welcome everyone. Before I start, I would like to get to know you, and I would like to talk like a brief moment about myself, so we can move forward. We can manage expectations here. So, who I am? I'm actually a former senior software test engineer, so I have lots of hands-on test automation experience, various platforms, and I'm right now PhD candidate. I will go my third year in September, and I am also part of the special academic staff. It's just a fancy way of saying researcher. So, and I'm also teaching software testing in University of Antwerp, Belgium, and I'm really happy to do that because I love testing. So, how about you? Are you familiar with the REST APIs? I see lots of notes, that's good. LLMs? Who doesn't use ChatGPT, right? Anyway, agentic LLMs? Some yes, okay, all right. And can I see hands? Test amplification. Who is aware of test amplification? Alrighty, okay. Not much, but okay. I will explain little bit of everything which you see here, so don't worry. So I will start by explaining test amplification. So it's relatively a new term. So if you don't know about it, it is, I would say, like pretty normal because I giving similar presentations in Netherlands, Belgium, and most of the people also was not aware of that because it's just new. And then I will tell you just a little bit about the system under test that I use for my testing approaches. And then I will show you agentic LLM systems and how we design these systems to get the best out of the technique test amplification. Then share the results, pretty straightforward, and then the conclusions. And on the conclusion part, I want to get to know your feedbacks. So what do you think about that? You might conclude some other things not like me. Maybe you saw other things. So, let's start. Test amplification. Test amplification is an umbrella term for improving your test suite. Here, the next question is, what is improving the test suite? Well, it depends on what your organization needs. In my case, my organization or my research aim to increase the API coverage so we can hit the boundary values and we can make sure that we increase the quality. That was our purpose. There are many types of test amplification, but today we're going to focus on that. And we're going to do that by generating more test cases using these methods. And you can say that, okay, it sounds good. You have like this magic box, you put there, you improve your test suite. How do you do that? Well, first it started with some search-based algorithms and other stuff, but today I will use, well, LLMs for it because I think it suits the best test amplification. So, was it clear? Yep. Okay, all right. And now I will tell you just a minute about what application we used for testing these approaches. And many might know Pet Store application. This is a representative application and a cloud application, which we need. Why we choose that? Because we have all type of REST API operation. It is open source, which makes it easy to work on, and no laws and everything. So, and open API specification is also available. So that's a huge plus. Are you familiar with open API specification or Swagger? Well, that's cool. Okay. Now, a bit more background. The agentic LLM systems. So, what does that fancy word mean? So first, there are single agent systems. So basically, in single agent, you provide an input or query, and then it got processed, then you got the output. For example, you go to ChatGPT, you say, what's the weather today? It responds to you. That's a single agent with a single input. There is nothing complex about it. And then there is multi-agent systems. You put the query, then there are a couple of LLMs, which we call them agents. And then these agents talk with each other. They coordinate. They pass values and everything. They do a lot of complex stuff. Then they integrate our output, and they agree on, OK, this is what we're going to return to the user. And they return you an output. So as you can see, this is far more complex than a single agent system, because it requires an understanding of LLMs APIs, designing the agentic systems, and it requires continuous communication between LLMs. And if something goes wrong with that, then your output might go in a wrong turn. So this is a little bit of comparison table. So I'm not saying that multi-agents are best in every way. There are like advantages and disadvantages, like they being complex. So right now, I will talk about our setups in single and multi-agent systems for test amplification, for generating test cases. So first, the single agent system, we basically have OpenAPI retriever. What it does is that you have a test case, then you need some information about the values, what parameters to pass, what headers to pass. The LLM needs to know that. And we do that by giving the OpenAPI documentation, and it retrieves information. These agents basically do that. And then there's a local executor. It executes the test cases. It gives pass and fail run test cases and syntax and runtime error. This was our baseline setup. It's relatively a simple setup. Now we have other setup. It's called multi-agent system. So this is far more complex. You can think, what is that? This is a lot to take in, but I will break down this to the chunks so you can understand what we did here. So the first one is the same one, the OpenAPI retriever. It just gets the information from the OpenAPI. That's its only job. This LLM sits there, gets the information, and passes it in our system. And then next, we have 3 different agents: header, parameter, and value. If you ever work with the REST APIs, you need to know that you need to test different type of headers, different type of values, and etc. And these agents focus, what should I pass to the generated test cases? What values should I pass to maximize the coverage? There are 3 agents. They focus on that. And then we have planner, writer, and executor agents. As you can understand from the names, they plan a test suite. What tests should we write? And then they write the codes in Java. We use Java REST Assured. And then the executor agent simply executes the test cases. But after that, if you ever generate it with a code with LLM, you know that it can be broken, or it can be even funny. There were some cases even it forgot import statement. It's a silly mistake, right? And I don't think a human needed for fixing that import statement. It is very simple, like even a small LLM can do that. So we have repair agent. When we got an error after we execute the test cases, this agent, this LLM specifically, looks the generated code. Oh, OK, you forgot here import. Oh, there's a typo there. Oh, this value is not supported by Java. Oh, there's a null pointer exception. Like, it fixes those type of trivial errors, so we have a clean code. So how about the results? We generated lots of test cases, improved the quality, or did we? Let's see. So we generated more than 100 test cases in both LLM setups. So the question is, are they good enough or not? This is just one statistic. I will share a couple of more. So more than half of the test cases were successfully passed. So good news. But we have also a lot of failed test cases. So These test cases are due to, well, almost half of them was exposing bugs. So it's a good thing they failed, right? But the other ones, we have some other issues, and we categorize them. When you generate test cases, Java code with LLMs, you have some other problems, and we categorize that. The first, it's the missing information. For example, LLM, if you don't have a comprehensive OpenAPI specification, then our system don't know what values to pass. You know, so it just stuck there, and they kind of hallucinate, or they just put some value in it because why not? This was like the first reason, and the second is semantically incorrect. It means that the LLM doesn't aware of what application does, like if it is the e-banking or like in a deeper level, it doesn't know the really deep specs because they are basically not available in the OpenAPI. So it was like basically wrong scenarios, wrong test cases. Like here, a human needed to fix that because it was just a wrong assertion or something like that. And also, even though we employed a repair agent, I claim that we fixed the import statements and everything, we still got some errors. Well, these are relatively low because if you remember in multi-agent, we have almost 150 test cases and only 4 of them failed. So it is acceptable in a way. How about the coverage? Like, first, we have initial coverage. This is a coverage with one test case we use as a baseline in our approach. So with one test case, of course, you have very, very limited coverage. And I must warn you, this is not a source code coverage. We don't have source code. We move with the black box perspective. This is API coverage. So in single agent and multi-agent, they both did, I think, quite well job because we only use one test case, one human written test case, and then we have lots of test cases. And if you look at the multi-agent, almost in all the cases, it beats the single agent. But this is something more or less expected because we put, more efforts in it, of course. But this is where I say it might not be the best because of that. So yes, multi-agent was better. You can clearly see that more bugs, more API coverage. If you call it more quality, you can go ahead and call it. But it takes 4 times more runtime. This is one thing. And it takes 2 times more tokens. And tokens means money. And besides from money, there's a big discussion going on with the LLMs and the environment, right? So we found out a way to actually calculate the energy consumption, and if you look at that, it's a wise amount. So we did this for one microservice, but many companies has lots of microservices, lots of systems, and if you have like the double, you might think, is this 10% or 20% worth it or not? You might think about that. But if your company is a safety critical company and you really need to be sure that your people are gonna be alive or so, then of course go for multi-agent because it makes so much more sense. So another thing, you can say that you have 150 test cases, okay? But are they good? Like, can my developers understand what's going on in the test cases, or they just trash, You increase the coverage, but how do they look like? It looks like this. If you ever coded with Java, rest assured, library, you can see that it is a very clear design, even a commented line, and it encourages actually the developer to add more test cases. And yeah, and this is the second example. This is even better because do you know what a data provider does in Java? Anyone? Data provider? Yep. Yep, you know that. Okay. Then you know it's the best practice. Because if you have 10 different types of inputs, you don't write 10 different test code. this is just a very bad way to write a test code, right? You just write a data provider, you put your data, and then you return to this object to your test cases. That's the best approach, and we didn't even state that in the LLMs. They just figure out by themselves, okay, in Swagger there are 5 different options, what should I do? Let's use the data provider. So, in conclusion, the first test case, first test amplification, the happy path is the key. Because we give one test case to these LLMs as an example. And when they see this example, they already know about your test architecture, your designs, techniques, or whatever you want. So if you have a good, clean test suite, in my case, my test suite was one test case, then there is a really good chance that you will have better results. And if you have more comprehensive OpenAPI specification, that's even better. Because we have OpenAPI Retriever, both in single and multi-agent. They will leverage that, and they are leveraging that very, very good. And you will get better results even. And I must say, you need to also set your goal, because our goal was to increase the coverage. Not to find out bugs, or we find over 40 bugs in the system. But it was not our intention. If we optimize this approach to find bugs, you can find more than 40 bugs. I'm not 100% sure, of course. Maybe there are just 40 bugs in the system. But our aim was the coverage. So it is important to put a clear goal when you're using LLMs for test generation. That's for sure. About LLMs, the best thing about is that they are naturally based about the natural language, right? They are basically language models. So they really produce a maintainable code, a readable code. You read this code, like it was so clean that it was like a senior engineer wrote that code. It was so clear, commands and everything, the variable names, even the naming conventions. It was so great. And whether you choose single agent or multi-agent setups, you have a high success rate. Well, you can define high, but you increase the test suite effectiveness. And overall, in every setup with multi-agent or single agent, whatever, you increase the test coverage, that's for sure. And you identified bugs, over 40 bugs. And, well, I mostly talk about how we set up the agents and how we orchestrate them. But the agent basically needs a prompt inside of it, right? In your development, you write a prompt, you pass variables. So the prompt engineering, it still plays a big role. Because we also saw that if we tweak the prompts in a best practice way, we also did before this study, we did a paper on prompt engineering, so we were experienced on that area. So we used that in our leverage to get better results. So I would say it is important. And the quality totally depends on your application. So if you are a safety critical system working on it, it won't work. Because the 80% of coverage is like nothing. I mean, you can kill a person and you depend on 18. No, it's not really possible. But if your organization is satisfied with the 80%, 90% of coverage, you say it's good enough to go live, then it's a really useful tool. So if you think that, dude, I didn't get like what's going on. Like I need more information. How about the source code? What it looks like, and something off. Please feel free to read. You can find all resources there. So this is about the prompt engineering part. It's right now you see archive version, but last week it got published on IEEE software, so there's also official version available. About the second paper, it's in the submission process, but it's still available on the online. You will find the source code about the first study, because it's published. About the second study, we right now keep the source code private, but we will publish them publicly available as soon as possible. And even you read those and still not satisfied or having questions, you can feel free to reach out to me. And what I want to know right now is that, what do you think about that? Thank you for listening. Yeah. Yeah. Before we finish, I think we have some time, like more than 5 minutes. Yes, questions. Yeah.
Amazing. As I said, I have always questions. What do I think about? Super interesting, right. But you brought up the point with the missing information, and if you have a more comprehensive OpenAI description, then you get better tests. Mm-hmm. Now, in the world of testing, we always have the problem that we don't have enough information. Yep. So what, or do you have like a, what is enough to really get something? That's what I'm wondering about, and that's what my thinking is like, that all sounds good, but I have to have a lot of information that actually that works. So I would like to know what is enough, roughly. I know it's a gut feeling, but to just share with us.
Yeah, okay, good question. All right. So, I don't want to sound political, but it depends on your organization. So, I mean, one organization can be satisfied and the other organization is not. But for doing our best, we are also currently investigating another project to actually getting information from the cloud application automatically. And we will put it in somewhere, then we will leverage it. And it will be like as much as we can. So this is like ongoing project, but yeah. Was that okay? Yeah, okay.
Thanks.
Yep.
I have two questions. I think first one is easy. You showed us evaluation,
yep.
The failed test cases.
Yep.
And
should I go there?
No,
yep.
It's not important. How did you evaluate it? It was evaluated by LLM itself or a human interaction? And the second one, yep. Do you have any simple criteria that we can go with single or multiple agents?
What do you? Okay, yeah. First, the first question. You said about the evaluation, right?
Evaluation, the failed test cases.
How do you do that?
Yeah.
Okay, so it's a good one because when we first started working on these areas, there were no fully automated evaluation. No, but we did that fully automated way. Like we had a tool. We found out a tool, but it was semi-automated, this coverage and stuff. We made it fully automated, but about the semantically incorrect, we had to look into that as a humans because we need to figure out, because we see there are no like explanations, enough explanations. We need to, so it's a still semi-automatic, but mostly, yeah.
Is it public? Can we access them?
So the paper itself, it is public. But the source code and the designs are not because it's in the publish submission period. Mm. So after the paper got submitted, of course, we will put it out there.
Yeah, the second one is
yep.
When you compare the multiple and the single agents,
yep.
Is there a simple criteria that we can go with one of them? For example, if our project is something like this, and then single agent is powerful enough, and then we can go with it, or any criteria that?
Yeah, I mean, this is difficult to answer because I don't know your organization. But I must say, if you have like complicated microservices, like connecting with each other, passing, I don't know, strings, integers, like all types of complex things, I mean, the single agent would be not suitable. Because it would think like straight up, for example, if you have some errors between the microservices, it won't fix it. But the multi-agent system, it will fix it. I mean, mostly. So we have like 4 test cases have not been fixed, but yeah. If you are more complex, I would suggest even better approach than that. For example, you can do, we didn't do like more than 1 iteration over the repair because of the token cost. But if your organization wants to make sure that you have clean code as much as possible, you can iterate over the repair agent.
Okay.
So you can fix that.
Thank you.
Yep. I think one more. We still have time. No worries. Yeah. All right.
Sorry. Hello. I just want to ask something about multi-agent systems.
Yes.
You use the different LLMs for the small tasks, right?
So I use different LLMs, but they were all GPT versions.
All right.
Yep.
Can we use the different LLMs for the same tasks to optimize the response?
Yes.
Okay.
Yes.
And I just want to know, agents talk to each other.
Yep.
Can we interrupt and to see what's going on between the agents to figure out where is the bug or error?
Well, yeah. If you want a deeper analysis, you can do that, but you need to modify the code. Right now, in our source code, we don't have that kind of analysis, but it might be very, very beneficial. That's a good idea.
Thank you.
Yeah. And there was this. Yeah. Nathan. Yeah.
I would like to ask about the multi-agent setup.
Yep.
The pet store open API has many endpoints in it. Does the multi-agent setup work for only one endpoint, or do you also use LLMs to create a combinations of these endpoints to create scenarios? I mean, does your multi-agent setup work in a loop for different scenarios?
Okay. Yeah. Actually, this question is one of the design decisions that we made. So what we saw is that if we don't loop over each endpoint, we don't get high endpoint coverage. So what we did is that we loop each endpoint with a specified open API specification, so we have high coverage. So we loop over each endpoint to make sure that we hit everything. It was like over 20 APIs in Pet Store, and we hit in both setups. And in multi-agent, we hit 20 out of 20. In single, we hit 19. Yeah. Do you have anything else, or one more? Okay, just one more. Okay, we are over 5 seconds, so.
I was wondering how you organize human oversight, because you automate a lot, but do you also, for example, have some exploratory testing involved?
The simple answer, no. So in this approach, well, the project that I'm working is called zero-touch testing. So our aim is that no human whatsoever, and then we test the application. Okay, this is like next to impossible, I would say, but well, this is almost no human interaction. I mean, the process itself, the running, the pipeline, no human. You don't even need to see the application. We just need a Swagger. We don't even need the source code. We just need a Swagger spec and one test case to baseline it.
Well, I just wanted to remind you of the AI Act that says you need human oversight.
Sorry?
I wanted to remind you of the AI Act, the law that says you need human oversight. So I think automation is great,
yeah,
but don't aim for 100% automation.
Well, this is more like defining your way out of there and making as close as possible.
Yeah, that's true.
And we don't like do well, the process itself, no human, but we as experts sit together after experimenting those, and we look, and yeah. But yeah, thank you. Yeah. I think we are done. We are over 1 minute, so thank you.
Okay, we would like to thank Tolgahan Bardakci for his presentation.